Okay, guys, in this video, we are going to talk about more problems. This is from your text, kind of like textbook problems and very similar to your quiz questions. So we're applying exponent laws to rational exponents. So what we do here is we have a product of two exponents, so which means we have to add the two powers. So 1 over 4 plus 2 over 3, common denominator is 12. And so we multiply by the 3's and 4's to get the 12. 3 over 12 plus 8 over 12 is 11 over 12. So the answer here is 8 to the power of 11 over 12. The second one, we are going to apply the quotient rule because there is a division here. So clearing up the space for us, we are going to subtract the two fractions. So it is 1 over 4, take away 2 over 3. Again, we need a common denominator of 12. So multiply the denominator of the 3 by a 4. And what you do to the numerator, you must also do to the denominator. And so here we have 3 over 12, take away 8 over 12, and that is negative 5 over 12. So because it's a negative, remember we cannot leave our answers as negative. So when we come here, we will write a to the power of negative 5 over 12. Because we cannot leave them as negative, we got to take it to the denominator and write it as e to the power of 5 over 12. In the third instance, we are going to use the power rule, which means we have to multiply the two fractions. So we have 1 over 4 times 2 over 3. So multiplying the 1 into 2, you get a 2. Multiplying the 3 into 4, you get a 12. Simplifying 2 over 12, you reduce it, you get that. So I have a power of e to the power of 1 over 6. And here we're supposed to change it to the indicated base. So I'm going to write 25 as 5 to the power of something. I know that 25 is 5 to the power of 2. 5 to the power of 2 is 25. So if I change it to that, applying power rule, I have 5 to the power of 4. So that's the change. In the case of 2, I know that 4 is 2 to the power of 2. Or if I do the opposite, the square root of 4 is a 2. So I'm going to substitute, instead of the 2, I'm going to substitute 4 to the power of half. So I have 4 to the power of half to the power of 3. And now I apply the quotient rule, the power rule, and I have to go half multiplied by a 3 is 3 over 2. So my answer is going to be 4 to the power of 3 over 2. In the last question here, what you find is you can never really write 8 to the base of 4 or 4 to the base of 8. That because they don't share a common base like 2 to the power of 2 is a 4 or 5 to the power of 2 is 25. They don't have that kind of a relationship. So we're going to change them to a common base and then work from there. So I'm going to write this as 8 as 2 to the power of 3 to the power of 2. And that is 2 to the power of 6. Okay, now I know from my previous problem, I can write the 2 as 4 to the power of half to the power of 6. Multiplying half of 6 is a 3, so that becomes 4 to the power of 3. Looking at the exponential equations here, the first one is really simple. I can write the right side as 3 to the power of 3. So 3 to the power of x is 3 to the power of 3. We have two exponents that are equal to each other. The bases are the same, and therefore it must be true that x equals 3. That is, the powers must also be the same. And we have 7 to the power of x minus 1 here. Change the 49 as 7 to the power of 2. And you have x plus 4. And now applying the power rule, I have to multiply 7 times 2 and I have to multiply 7 times 4. Oftentimes I find students forget to multiply the 2 into the 4 as well, and they will simply have it as a 4, not as an 8. So let's not make that mistake here. So we have 2x plus 8 and 7 to the power of x minus 1. And so because the two exponents are equal and they have the same base, the powers must be equal. Okay, to simplify this expression, take the x to one side, the 8 to the other. 8 minus 8 minus 1 is 2x minus 1, or minus 9 equals x. Okay, hold on to this, because the very last thing on a quiz and a test you're going to do is to verify if this answer is correct. Now I'm going to show you how to verify if a given answer is the correct answer for the equation that you have. So making some space here, this is the answer we have. We're going to divide the space here into 2, like so. And then on one side, I'm going to write the left side. So that is the left side of the equation. That is the right side of the equation. So the left side is x 7 to the power of x minus 1. The left side is 49 to the power of x plus 4. So now I'm going to take the negative 9 instead of the x here. Instead of the x here, I'm going to substitute that. Okay, and I get 7 to the power of negative 10, or I have 1 over 7 to the power of 10. Now let's substitute on the right side as well. So this is 49 minus 9 plus 5, and that is 49 to the power of negative 5. Oh, I'm sorry, making a mistake here. That is not a 4. That's not a 5. That is actually a 4. So I have here negative 5 and 1 over 49 to the power of 5. Now you can put this into your calculator and actually find very large numbers that are equal on both sides. But I'm going to do something using exponent laws. So 7 to the power of 2, I know is 49, is to the power of 5, and I find that both sides are equal. Since the left side equals the right side, I know that x equals minus 9 is my correct answer. So you're expected to do this for a few questions on your quiz and on your test. See you in the next video.